Hi, welcome back. This series of sessions, we are looking at Datasphere concepts in detail. In my previous sessions, I started introduction to Datasphere and explained the basic concepts like space creation and repository explorer. And then I started with business builder and data builder apps in Datasphere system. After that, I started creating simple data flow objects in data builder app. And then I added little complexity by introducing Python script operating in data flows for advanced transformations. In today's session, we're going to focus on ETL objects or data integration objects in Datasphere. The objects are remote tables, data flows, replication flows, and transformation flows. We're going to create these objects in the Datasphere tenant or trial system and understand how they are created and how do we configure the transformation logics in these objects. Before we go on and create these objects in Datasphere system, let's understand the concept of ETL or data integration in Datasphere. Data integration concept starts with extracting the data from source systems like S/4HANA, on-premise or cloud, ECC, databases like HANA Cloud, HANA on-premise, could it be BW system, or it could be any other non-SAP databases like SQL Server or Oracle databases. So we have several connectors given or provided by Datasphere. So we extract the data from these source systems using these connection types and then stage the data in Datasphere and then transform the data into a reporting requirement format. In order to stage and transform the data in Datasphere, we use one or more these objects in Datasphere. These objects are remote tables, data flows, and replication flows. With the introduction to the data integration concept in Datasphere, let's take a look at these objects in a picture format. So in this diagram, I have source system and then get different connections as I explained to be able to connect to those source systems and extract the data as required. And then we got objects in Datasphere like remote tables, data flows, and replication flows. And then you got to also see transformation flows for complex transformations after data replicated using replication flows. Let's understand the concept of these objects and what are the best practices to do these different objects and in terms of reporting requirements. And then we can go into the system and then prepare these objects or develop these objects and see how they are created. We'll start with remote table. So remote table is the concept as virtual table from Smart Data Access in the past in native HANA. Smart Data Access capabilities, similar concept you can understand for in Datasphere as well. So remote table is created as a data integration object using one of the connections related to that source. And then remote table is created in Datasphere, and then it provides access to the underlying source system table or views. And then on top of those remote tables, an analytical model can be created in Datasphere. And of course, that can be consumed by analytics cloud application, SAC. We have another option to replicate the data. Sometimes we may experience performance problems with the remote tables. Virtually accessing the source objects could be really challenging. Sometimes metadata cannot be provided or integrated using remote tables. Like the remote table will be created as a flat structure instead of um, objects, filters and joins and etc. couldn't be applied in remote table. In those cases, the performance could be really a challenging aspect. In those cases, we would like to persist the data or replicate the data in Datasphere by using a concept called replication. Using this replication process, you can do a snapshot. A snapshot is a full data load, or a real-time replication, which enables the change data capture in the source system, and then the respective changes are recorded in the remote table real-time replication target table. In order to configure the remote table, we use two on-premise installation or client applications, you can call it in that way. They are DP agent, smart data integration, data provisioning agent, and then we also have cloud connector, SAP cloud connector, which is also going to be installed on-premise within the source system network, most likely if it is an on-premise connectivity. And then using that connector, you can establish the connection to SAP on-premise systems and create remote table and or use those remote tables in analytical models. By using Smart Data DP agent, Smart Data Integration DP agent, you can connect to SAP source systems as well as non-SAP source system, especially non-SAP source systems you can leverage in a more better way, and then start by using one of the adapters that are provided by Smart Data Integration DP agent. You can connect to different databases or application, and the data can be replicated into Datasphere. As I said, DP agent is going to be on-premise installation, so it's going to work very well for on-premise source systems. But for source systems like S4HANA Cloud, it's not really going to make a lot of performance benefits because of the reason that two cloud systems, one is Datasphere on the target and S4HANA Cloud on the source side. In between, we we are requiring a client tool called Datasphere, which doesn't really have to be the case. So that's why there are advanced data integration source system types given. Those source systems types can help to create the remote table or to create the actually to create the replication flows as another object. But in general, we try to have the DP agent for non-SAP systems, especially on-premise one, and Cloud Connector for SAP systems in the source system for virtual access. So that's more about federation or replication using remote table object in Datasphere. Then move on to the second object. This is data flow. Data flow is a kind of a batch task or kind of transformation object. Um, like in SDI, we used to have task flows or data flows similar to that concept. So we can access the source system objects using one of these connections and then connect the target system, which is Datasphere DB local tables, and then apply the transformations using data flow operations like the join, filters, and etc. You can also apply Python script using NumPy library or module, which is readily available and embedded in data flow object. So you can just like that, you can write or you can use the Python module NumPy without or pandas without having any other additional installation needs to be done in Datasphere. And the next object is replication flow. This is the most important object that I would say, replication flow, and along with the transformation flows together uh, play a major role and satisfy most of the data integration needs in Datasphere. Currently, replication flows are used for simple data replications and also some complex transformations using transformation flow. But in near future, it is going to get all the current capabilities of data intelligence on cloud, which is DI cloud or data hub, we can call that. All those capabilities will get implemented in replication flow and trans transformation flow together. So when that happens, you will be able to do the pipeline object using replication flow and transformation flows. You can apply the complex transformations, and you can also have the Python runtime running here to be able to perform machine learning and advanced predictive capabilities as well. So as we go and more deeper into the data integration concepts, and that's when replication flow will become more important to us. And currently we have three use cases for replication flow, three types you can call. They are use case one, which is going to be inbound data movement, getting the data from source systems and store the data in Datasphere local table, which is going to be a replication from source to target with minimum or no transformations in between. Those other than filter and mapping or selecting the columns, there's nothing else that we can do when creating replication flows. As I said, it is always going to be a transformation flow after a replication flow that will fulfill all the transformation or data integration needs once the data is replicated in staging table. And the second use case that I wanted to talk about is outbound data movement. So from Datasphere, you have the staging data table, and then uh, we would like to send this data to the outbound systems or target systems like Google Cloud, Azure, or HANA Cloud, and some of those target applications. You can see the number of target applications here, and these number will go um, more and more in near future. And then last one is pass through. So we don't have to store the data in Datasphere. We connect to the source system um, using all the existing source system connection types. And then we also connect to the target system. As I said, these are the target systems. There may be Kafka, another one that needs to be added, but most likely, most accurately, this is the current target systems list. And then you can use the Datasphere as a middleware or ETL tool to transform the data and send it to the outbound target. And out these two use cases, sending the data out is always called as premium outbound capability. And with this premium outbound capability, there's going to be an additional charge always applied for doing so, along with your regular consumption of your Datasphere tenant. Capacity units will be allocated to that, but premium and outbound integration costs you a little more. So that's about the ETL objects or data integration objects in Datasphere. So we're going to look at how do we create these objects in the system in the next session. Thanks for listening. Bye for now.